Section 1.6, polynomial and radical equations. We're just going to hop right into our first couple of examples. For our first example, let's look at 6x cubed minus x squared minus 2x equals 0. What's the highest power here? X cubed. So this is a cubic equation. So we haven't talked yet about solving cubic equations. The best way to handle polynomial equations that are greater than the square is hope they factor. So can I factor anything out of there? X, yeah, that would be my GCF. So we're going to take an x out. And that will leave us with 6x squared minus x minus 2 equals 0. Now we're left with a quadratic. So we've already factored it down from cubic to quadratic. And let's see if we can get the quadratic, the 6x squared minus x minus 2, to factor further. If you didn't want to factor further, you could just set each factor equal to 0 now and solve by the quadratic formula. But let's see if we can get it to factor. Do you guys want to use bottoms up?
Yes.
Okay. Let's see if we can go further. We already have the x, so we have to keep it. Then we'll take the 6 and multiply it by the 2. And sure enough, what's in the parentheses will factor into x minus 4 and x plus 3. But we have to remember, what did we multiply through by for bottoms up?
6.
So before we go any further, we have to divide that back out of the two factors, here and here. Now both of those will reduce. So we have x times x minus 2/3 times x plus 1/2, all equal to 0. So at this point, you can go bottoms up, but you don't actually have to. Do you guys understand that? Since it's a solving process, can you look at this and see that x can be or 2/3 or negative 1/2. So you don't have to go all the way with bottoms up when you're solving, but you have to go to this point where you divide back out your leading coefficients. So if it's going to confuse you, just go all the way like you always have and then solve from there, which is what I'm going to do. From here, we set each factor equal to 0 and solve for x. We know that the first x could equal 0. The second one, positive 2/3 would make that 0. And the third one, negative 1/2. So those are the three solutions to that problem. Let's look at this part B. X to the 4th minus 5x squared plus 4 equals 0. That is a trinomial. It's to the 4th power, but there are no common factors. So you can't use GCF to get this started. So we have to hope that that trinomial will factor into two binomials. Let's see if it will. Now, if I'm going to split x to the 4th, I can split it to x squared and x squared. And the last factor, the last coefficient is a positive 4. So I need two numbers that multiply to positive 4 but add to negative 5.
Negative 1 and negative 4.
Negative 1 and negative 4. Okay, so now that brought it down from a 4th degree equation to a 2nd degree. We know how to solve quadratics. We can solve quadratics. We have two quadratics here. We could solve it by factoring, we could solve it by square root property, or by completing the square or quadratic formula. In this case, they both factor further. So let's just go all the way. X squared minus 1 will factor using the difference of two squares into x plus 1, x minus 1. And x squared minus 4 will factor into x plus 2, x minus 2. Then I just have those 4 factors to set equal to 0 and solve for x. So x plus 1 equals 0, which yields what answer?
Negative 1.
And the second factor, x minus 1 equals 0, would yield positive 1. X plus 2 equals 0, gives us negative 2. And if we set x minus 2 equal to 0, we would get positive 2. So there are the 4 solutions to x to the 4th minus 5x squared plus 4 equals 0. And we should, of course, substitute each one of those back in and check it. Okay, now let's look at equations that have rational exponents. So here we have 2x to the 2/5 minus 5x to the 1/5 minus 3 equals 0. So we have a trinomial, but the exponents are fractional. You can still try to solve them by factoring, as long as the highest power is twice the middle power. Or in other words, the middle power is half of the largest power. And that is the case here, so we are going to try to factor this using bottoms up. So we'll take the 2 and multiply it by the -3, and that gives us x to the 2/5 minus 5x to the 1/5 minus 6 equals 0. Then you take your two parentheses, set them up, and you know that what has to go inside the parentheses is going to be the middle variable. So we're going to put an x to the 1/5. We're going to split the first variable in half and put 1/5 in each. So we have x to the 1/5, x to the 1/5, and then you treat it like a regular factoring problem. I need two numbers that multiply to -6 but subtract to -5. -6 and +1. So we'll put -6, +1 here. But we have to remember that we used bottoms up to get there. Now look, guys, that distributes back out. Check it. X to the 1/5 times x to the 1/5. When you multiply, you add your exponents to get x to the 2/5. Outer, these two multiplied together give you +1x to the 1/5. These two give you -6x to the 1/5, which combines to -5x to the 1/5. And last times last gives you -6. It does FOIL back out. It looks weird, but it works. Now we have to divide back through by 2, because that was our leading coefficient. So divide by 2, divide by 2. Simplify, x to the 1/5 minus 3, and x to the 1/5 plus 1 will not, 1/2 will not simplify, so we'll just go bottoms up. And that gets it factored. Still doesn't look pretty, but it is factored. Once you get it factored, take each factor, set it equal to 0. So we know that x to the 1/5 minus 3 has to equal 0, and that 2x to the 1/5 plus 1 has to equal 0. And then just solve them separately. For the left one, add 3 to both sides. X to the 1/5 equals 3. And then we have to do something to get rid of the 1/5 power. Does anyone remember how to solve that once you isolate x to the 1/5?
You do 3 to the 5th power.
It's multiply times.
You, right. You're all saying it kind of different. Not multiply by the reciprocal though, but raise it to the reciprocal power. And in this case, what's the reciprocal of 1/5? To the 5 to the 5. So you raise both sides to the reciprocal power. And that produces x to the 1 equals 3 to the 5th. What is 3 to the 5th? 243. 243. So there's one of our answers. On the other side, we're going to subtract 1 and divide by 2. So that x to the 1/5 equals -1/2. Then you do the same thing. Raise both sides to the reciprocal power. So we're going to raise both sides to the 5th power. And that will give us x equals -1/2 to the 5th, which is -1/32. Everybody double check that. -1/32. So those appear to be the two answers. But just like with radical equations, when you have fractional exponents in your equations, you need to check the answers. So let's take a couple of minutes, go to our calculators, and check both of those answers now. Okay, so we used the store function on our calculator to check both of these, and we found that they both make the original equation true. So we can keep them both as our answers. So x equals 243 and -1/32.